And welcome to the final trig lesson for our 3C course. We've mastered SOHCAHTOA, the trig ratios. We've mastered sine law. Sine A over A is equal to sine B over B is equal to sine C over C. We've mastered cosine law and the 6 different versions that are all incredibly long and we won't bother going over right this second. And we've mastered how to pick which one to use in any given situation. The only thing we haven't seen is when we have more than one triangle at a time. So how are we going to approach these? Well, the idea is we're going to look at the triangles and see which one has enough information that we can solve for something. And preferably something that will give us information about the second triangle. And then we'll use that to solve for the final one. So one triangle will be able to get us information about the second triangle. So it's something that's shared, usually a side, sometimes an angle you can figure out. And then we'll use that to solve for what we're actually after. So we've got a triangle here, D, E, F, and G. EG is splitting it into 2 separate triangles. And it says we want to find the length of side DE, which is the one over here. Let's call it little g for this one. Now technically this could also be little g, but we'll see it won't matter this time. But you will have to be a little careful how you label things in these sorts of problems. So we want to solve for g. This is what we're solving for. So whatever we're doing, we will need to use this triangle. But if we look right now, we have one angle and we don't have the other, we don't have any of the sides, and without any of the sides we can't use our SOHCAHTOA rules. So we're stuck. So we have to look at the other triangle. So we have the triangle EG and F, and it's another right angle triangle. This time we have an angle and we have a side. Now the question doesn't tell us what we have to do, so we have to think about it. We have 2 pieces of information in this red triangle, so we can solve for anything else in here. We can solve for that angle, or this side, or this side. We've got options. But we don't want to just do it at random. We want to think about what information we want. If I need to solve something in the blue triangle, I need to look for something that's shared between the 2, which is going to be that side right there. So let's call it X. So if I can use the red triangle to get X, then I can use X and the 40 degrees to get G. So it's a 2-step process at minimum for these questions. But let's find X. So if that's my reference angle, because if that's a right angle on that side, then it's also a right angle on that side. So I do have right triangles. It is a SOHCAHTOA problem. From here, this is the opposite side, and this is the hypotenuse. So we are using sine law. So sine 60 degrees is equal to x over 9. Put that over 1 to make it a proportion. So x is equal to 9 times the sine of 60 degrees over 1. And how did we get that? Well, we did our z pattern. X is equal to the sine of 60 times 9. I always write the number first, but the order doesn't technically matter. Divided by 1. The reason I do that is sine 60 times 9. If I'm sloppy, I might do sine 600 times 9, or if I do a times, I might multiply the 60 and the 9 and then do sine. I just find it less clear. But if you're really careful, you can do it that way too. So let's solve for this then. Handy dandy calculator. Make sure it is in degrees as always. 9 times the sine of 60 degrees. Divide by 1. Let's keep an extra decimal point since we're in the middle of a problem. So 7.79. Normally we do 1 decimal place for side lengths. we're in the middle of a question. Let's keep one extra bit of information. So this is 7.79. And now I can look at the first triangle, my blue one. And from here, I have opposite and hypotenuse again. So it's sine law, or sine SOHCAHTOA. It's our sine trig ratio again. So sine of 40 degrees is opposite 7.79 over hypotenuse, which is g. We put that over 1. We use our Z pattern. And we get g is equal to 1 times 7.79 divided by the sine of 40 degrees. So 7.79 divided by the sine of 40 degrees gives me 12.1 centimeters. And that is our final answer. So this one was nice. It was both trig ratios, but the important thing is to get the flow. I'm going to use one triangle to find a piece of information about the second triangle so I can solve the second one. Now, when they're not just trig ratios, they get a little more complicated. So here's one, and this is a really cool example that can be used in real life. So this can allow us to measure the height of something without being able to get to the bottom of it. So say you're looking at like a flag on top of a building. Well, you can't get to the base of the flag, but with this technique, you can actually solve for the height anyway. So what do we have going on here? We've got a nice right angle triangle. So that would be a SOHCAHTOA or Pythagorean theorem problem. But I only have one piece of information and one unknown. So I'm stuck. So let's look at the second triangle we have. So we've got a triangle here as well. And let's see, I know one angle and a side. It's not a right angle triangle, so it's got to be sine law or cosine law, which means I need at least 3 pieces of information. I've got one angle, one side, and now I'm a little bit stuck. But I don't know how far back we have to go for this one, but if you remember back far enough, I don't know what's happening there. Sorry about that. If we have a straight angle, it has to be equal to 180 degrees. So because of that, I can find angle R, right? I can find that angle because I know that it plus 45 has to be 180. So that means angle QRP is equal to 180 degrees minus 45 degrees, which is 135 degrees. Now, why did I write QRP? In case you're curious about that part. So since if I say angle R, I don't know if you mean this one or that one, we write the angle with 3 letters instead. So this is the angle for Q, R, and then P. So it's basically saying it's the angle in the middle of those 3 letters as you travel from one to the other. So it's just a way to help clarify which angle you're talking about in that context. So now I know this angle is 135 degrees. So does that give us what we need? Well, we can call this X, because if we can get this side that's shared, we'll be able to do our SOHCAHTOA. So there's one loopy, right? 30 degrees and X are opposite each other. But I have 135 here, and I don't know the side opposite. So that doesn't give us our second loopy. So what do we do now? Well, this is the classic sine problem where we know two angles, but not the one we need. But we can get this one at the top because we know that the triangles in a triangle have to add up to 180. So angle QPR, so going this way for P, so we understand that it's the side we want and it's not that side, is equal to 180 degrees minus 135 degrees minus 30 degrees, which is 15 degrees. So that one is 15 degrees. And we're finally ready to solve this problem because now we have our second loopy, which is the 15 degrees and the 30. So our first triangle, we're going to do sine of 15 degrees over 30 is equal to the sine of 30 degrees over x. And it is Z pattern. To solve for sine law, x is equal to 30 times the sine of 30 degrees, all divided by the sine of 15 degrees. We'll do that on our calculator. 30 times sine 30 divided by sine of 15 gives me 57.96 meters. And now we go back to our first triangle and we have SOHCAHTOA. So from our reference angle of 45, that's the opposite, and that's the hypotenuse, and this is, and we know x is 57.6. So it's sine law again. Lots of sine law today. Or not sine law, it's the sine ratio. Sine of 45 degrees is equal to the opposite, which is h, over the hypotenuse, which is 57.96. Put that over 1. Do our Z pattern. And we get h is equal to 57.96 times the sine of 45 degrees divided by 1. Divided by 1 doesn't do anything, of course. So 57.96 times sine of 45, and we get 40.98 or 41.0 meters. And that's how tall the top of this object is off the ground, even if we can't get to the base to measurement. So as an experiment, say, I don't know, this might pop up on a culminating trig task at the end of the year. If we needed to measure the height of this object and couldn't get there, we could use our clinometer to measure one angle to the top of the object. Then we could measure our distance to a second position, and then use a clinometer, it just measures angles, to measure a second angle to the top of the same thing, and we could use this method to find the height of it. Not that I'd give that to you on, a culminating task or anything, but who knows, maybe. All right, last one. We're going to try solving for angle theta in this problem here. So no right angles to be found. Some of you might have the instinct to say, well, theta looks kind of like 90 degree. We can just assume that's 90, but no, we can't do that. We can never make that sort of assumption. I want to use this, I need to solve this triangle, but I don't have enough information. I can't make a loopy with that one because I don't know the angle. I can't make a loopy with that one because I don't know the angle. And I can't find the angles because I only know one. So I'm stuck. But that's what we should expect when it's a two triangle problem, right? The triangle with the information we're looking for, we won't be able to do. So we have to look at the other triangle first and try and get some useful information. Probably the length of this side here, x. Well, we already have x on there. Well, what do we call it this time? How about y? So what can we do in this triangle? Well, we'd have a loopy there, and we'd have a loopy there if I knew the angle. But I can find the angle because I know the other two, and the angles in a triangle add up to 180. So let's do that first. What do we want to call that? Let's think clever how I want to label this. Let's use A, B, C, and D. And you'll see why in a minute. So that is angle D to A to C. So angle DAC is going to be 180, because a triangle has 180, minus 70, minus 60, which gives us 120, 50 degrees. Yep, I think that's right. And now that I have 50 degrees there, now I've got, oh, there's a mistake with this problem. All right, silly me. Let's say that shouldn't be a variable then. That should be 21.8 centimeters. 21.8 centimeters. And now we have a sine law to give us y, and then we can get theta. So sine law, we have sine of 50 degrees over 21.8 is equal to sine 70 degrees over y. We do our z pattern. Y is equal to 21.8 times the sine of 70 degrees divided by the sine of 50 degrees. And that works out to 26.74 centimeters. So this is 26.74. And now we go back to our original triangle and we look at what we've got. Well, I still have no angles, so I still can't do loopies, which means it must be cosine law. And I've got all three sides. And that is one of my conditions for being able to use cosine law. So this is going to be cosine law for an angle. All right, so that means the cosine of angle B is equal to, well, let's label our sides. It's going to be a squared. That's not how you write a 15. 15.0 squared plus 20.2 squared minus b squared, which is 26.74 squared, all divided by 2 times a, 15.0, times b, which is 20.2. And you do all that on your calculator, and your numerator should work out to negative 81.9876. I just kept all the decimals because I was in the middle of an equation. And the denominator should work out to 606. So that's still cos of b. So cos of b is equal to negative 0.1353 if we round it to 4 decimal places. And then to get b, we do the cos inverse of both sides, and you get b is equal to 98 degrees. And angle b is angle theta, so that is our final answer, and we're done. So these ones take a little bit of time and a little bit of thought. First, identify which of the triangles you're solving for, and then say which piece of information you need, and then look at the second triangle and see if you can solve for that piece of information. Do that, and then you sub it back into the first one and you get it done. So it's really just doing 2 trig questions back to back. Remember that the angles of a triangle add up to 180. Remember that the angles in a straight line add up to 180. And that should be all you need. All right. Have a great day.